In terms of skeletal system, the important things to really be able to do is you need to understand the structure of your long bones and essentially the functions. So like that it's important for mineral as a mineral reservoir, it's important for homeostasis, it's important for triglyceride storage, and that's in addition to the other functions in terms of support, protection, and movement. All right, so functions of bone, you definitely need to know. You will get that more likely in multiple choice than anywhere else, but you still need to know that. The bone shapes, don't worry about, that was all in the other exam. And then, but you need to understand how, and this is for muscle too, we'll do it when we get to muscle, is how that each bone is an organ. So in fact that bone is composed of a number of different tissues, just like muscle is composed of a number of different tissues. So yeah, you need to know what those tissues are and like how they function and where they're situated. Regions in a long bone, you need to know that, and what happens in those areas. So essentially the epiphyses are mostly for hemopoiesis, whereas the actual shaft of the bone is for triglyceride storage, for the blood vessels, and also for structure. The linings and all that you need to know, and that is all multiple choice stuff. All right. Okay, so this is the section now where we actually will get to bone formation and stuff, and this is what you'll get asked longer questions on. All right, so okay, osteoblast, osteoclast, and then bone formation. So all those definitions, what's an osteocyte, what's an osteoclast, what's an osteoblast, what are their functions? They're all important to know. And then the big thing here is the structure of compact bone. You don't have to know the structure so much, but the actual that you did in your exam, sorry. It's not the structure, bone formations. I'm just looking for that. Structure of spongy bone. You need to know the difference between spongy and
compact.
Yeah, compact bone. All right, but essentially only for multiple choice. I just want to check this. Okay, so for ossification, what happens in the fetus? Okay, there's also multiple choice on that. So essentially that the embryo largely has hyaline cartilage, and that slowly gets replaced during the fetal and early childhood stages with the normal compact bone, and obviously then development of the epiphyses, and then also the growth plate that eventually will fuse when a kid is in their late teen years. So, but that's all multiple choice type stuff. And I think this is the bone formation, which is bone remodeling. Yes. Okay. So this is where we really need to get stuck into the long questions. All right. So there are phases with bone remodeling. So you need to all the stages. So the first one is bone resorption. So you remember that during bone resorption, actually you've got the osteoclasts that are destroying the extracellular matrix that needs to be replaced. All right. And they basically, their function is to release enzymes, and that digests up the collagen fibers, and the acids also dissolve the bone minerals, and then you create like a little gap in the bone or tunnel. The calcium goes into the blood, and the rest of the substances gets chowed up by macrophages, and that happens in the next phase. Sorry, let me just So you need to know the phases, like the headings. Sorry. My cursor is going all over the place. Okay, so the next phase is reversal. All right, so you know reabsorption, reversal, and that's when the phagocytic cells basically come and eat up all the rest, and the mononuclear cells replace the osteoclast and prepare the bone surface for the new bone to be laid down. So here you just need to be able to stress the importance of getting rid of all those enzymes and acids, because if you try and lay new bone on tissue that's already got a whole lot of acids and enzymes, that bone's not going to last very long with new tissue. All right, so that's basically a function of the reversal stage. All right, and then the next phase is actually your bone deposition stage. All right, and that's basically the osteoblasts now laying down more bone and it becoming mineralized, and now the calcium returns from the blood and basically gets deposited in the bone. All right, osteoblasts, you need to also know that some of them do get trapped in the substances and then they become the sites, and others basically congregate, like you can see in here, they congregate around the edge. All right, so those are the common places for the osteoblasts to be, around the edge of the bone, like just under the periosteum. And then some of them obviously will get trapped in there and they will become the sites that now get stuck in the lacunae.
So, Linda?
Yeah.
What did you say happens to the ones that don't get trapped in their own matrix?
They just hang around under the periosteum.
Okay, yeah.
Yeah. All right, and then you've got your resting phase where basically nothing is happening. All right, so those are essentially your 4 phases. Okay, are there any questions on that? Because this is definitely a longer question and you need to know those 4 phases and describe what happens in each of the 4 phases.
Hi, Linda. You said it's 4 phases. I'm only seeing 3.
Yeah, the last one is a resting phase.
Okay.
Yeah, the last one is resting phase.
And nothing happens there. It will just...
Nothing happens there. It's basically in between everything else.
Okay.
This is what we did in our workshop.
Did you do it in the phases like that?
Yeah,
Yes, we did this. Can you see that, Linda?
Yeah, we did that, and we also we wrote a post workshop question on it. Well,
yeah,
we had a choice to do that if we wanted to.
Which is something I need to actually go and check today, is all those post workshop things. The next last. So I think in workshop, I'm just checking what she's giving you, what the term she's given you in workshop, but essentially, did you resorption, reversal, and I just want to check. I think she did call it. I just want to check if she's called it resting. That's all.
She was definitely resting.
She definitely called it resting.
Yeah.
Okay.
In the resting stage, she said that there was a prolonged period with little activity. The bone surface was covered with flattening cells, and some osteoblasts trapped in the matrix become osteocytes.
Yeah. So yeah, she's got resorption, reversal, formation, resting.
Yeah.
So those are your 4 phases that you need to know and what happens in each phase.
Yeah. She was big focus.
Yeah. Big focus means big question.
Yeah.
All right.
Right. Wonderful.
Yeah. So wherever, like in the workshop, there's been lots of focus, you can almost be guaranteed you're going to get a longer question on that. Okay. So, all right. Now, how does it differ when you model and don't remodel? Because that's another thing that you need to understand. Like, in what situations would bone be modeled and not remodeled?
Okay. Modeled and not remodeled.
If it was just the first time it was forming?
Yeah. So in what situations would it be the first time it was forming?
Growth.
Yeah, growth. So in kids when it's growth, what else?
A callus?
Sorry?
Like if there's a bony protrudence or a callus or arthritis or one of those type of.
Yes. What else?
Fracture repair? No.
Fracture repair. All right. And obviously in the initial phases when bone gets basically made from cartilage in the fetus and early childhood, that's the same thing happening, but that's part of growth. So fracture repair.
Mm-hmm.
All right. So that is the difference. The difference between modeling and remodeling is what?
That there's no resorption phase.
Yeah. There's no resorption and no reversal. All right. So basically all that's happening is bone is being formed and resting and formed and resting. Does that make sense?
That's in modeling.
That's in modeling.
It's formed and resting.
Yeah,
Okay.
formed and resting, formed and resting, formed and resting, because you're actually just making bone. And the same thing applies, for example, if suddenly you've got a person who's never been really athletic and they start taking up a sport and they're using a certain bone a lot. So for example, tennis players, the hand that they use to play with, so in other words, that holds their racket, the bones in that arm are like substantially bigger than the bones in an arm that they don't use. All right.
Yeah.
And you see that with hockey players or ice hockey players, and not so much golf but even then. All right. So whenever you are using a bone more than you would have used it before, that bone starts to become modeled. In other words, it gets bigger to take the strain that is required. All right. If you've never been a walker and suddenly you start taking up walking or running, your leg bones will develop substantially. All right. They will get bigger. And that is because they now are taking weight a lot more. All right. Even people who do weight training and so their bones get bigger because their muscles are pulling on their bones more. All right. So that's also a case of bone being modeled and not there will be remodeling happening, but obviously that growth that occurs or that development in that bone to make it bigger is modeled. It's not remodeled. In other words, you don't have to take something away to add it. It's just bone being added. Does that make sense?
Yes.
Yeah.
Yeah. So you need to understand the difference between the modeling and the remodeling. That'll be more multiple choice, but you need to understand that.
Mm-hmm.
Linda, and I'm sure you've said this before, but you said there'll be short answer questions and then long answer questions. How long will the longer answer questions be?
Well, that depends on the question. Some of them are like pretty short, like 1 or 2 marks each, whereas others are like substantially bigger. We're talking about like the longest one is on digestion and it's 12 marks.
Can we answer it in point form, or do you want us to write it in?
No, you can write it in point form. Just make sure that you give enough information for the amount of marks it is.
Yeah.
Yeah.
So, Linda, just on that, you said that we would have to know 2 of the digestive processes, right?
You need to know them all. You will be asked on 2.
We'll be asked on 2, so we don't know which 2, so we just need to know them all. Okay, then.
No, because you will be asked on all of them in some place. So 2 of them will be in the long answer question, but the other one will be in short. Like,
Yeah.
I mean, in multiple choice and stuff. So you're going to have to know all of them.
Okay.
Yeah. Yeah, the only one that you don't have to concentrate as much is nucleic acids. So the nucleases and that is like, I wouldn't spend too much time on them, but certainly protein, carbohydrate, and fat for sure.
If we were going to talk about protein digestion, would we be expected to include nucleases in that? No.
Oh, I think you did the other day on your sheet. I
did include it, but you would be only marked on the pure protein for
Oh, okay.
Unless it's specified nucleic acids, but we haven't given you nucleic acids.
Okay then.
Yeah, it's
Okay.
such a small little component that's different for that.
Right. Okay then. Okay, I'll take it off.
All right, and then the other thing was fracture repair, and this is also more related to the multiple choice than anything else. All right, but essentially you just need to understand what's happening with fracture repair. And if you can remember wound healing, it's basically going in exactly the same pattern. Basically, the first thing is always your hematoma, so you need hemostasis, all right? And with that occurs inflammation, all right? So you have hemostasis and inflammation, and basically the inflammation increases the amount of macrophages in there, and in wounds it increases the amount of fibroblasts. Fibroblasts in bone is going to increase the amount of osteoblasts, all right, to the area. All right, so fibroblasts migrate to the area just like it does in another wound, all right, and that restores the connective tissues, and the osteoblasts start laying down the bone. The macrophages, just like happened in wound, phagocyze any dead tissue, and then you get your capillary buds forming and replacing the blood supply. All right, so it's exactly the same phases as wound healing. All right, it's just it has slight, well, obviously the names of the tissue is slightly different. All right, so it's osteoblasts in addition to fibroblasts, etc. Does that make sense?
Yeah.
Yeah. So that's important just to to know these stages of. You won't have a long answer on that. It will be multiple choice, but you need to be able to understand how bone repair works in the same way that wound care would work. All right, we've got a long answer. You've got a long response answer on wound healing, so we're not going to give you a long response as well on fracture healing, but essentially the process is the same, and there is questions in multiple choice on it.
But we will have something with bone remodeling.
Oh, sorry, there are two people talking. Sorry, who was first? Emma? Was it you?
There's a long response on wound healing. There's also one on fracture healing. Or it's just similar.
There's multiple choice on fracture healing, and you have a long response in wound healing.
Okay, thank you.
Yeah, your sound. Sorry, Emma, your sound was just a little bit fuzzy. I don't know if it's your mic or something. That's fine. I heard you. Okay. Oh, and then basically there are some multiple choice questions also relating to the factors that contribute to bone growth and the factors that contribute to things like osteoporosis. All right. So you need to remember things like vitamin D is important, and your calcium minerals. Exercise is vital. All right. So weight bearing exercise is vital for bone development. All right, and then obviously you need to make sure that you have the right hormones. So people obviously, when their sex hormones start falling, that higher risk for osteoporosis because the sex hormones actually contribute towards bone formation. All right, so just those things in terms of nutrition and exercise are important to understand in terms of bone growth. All right, was there any questions on this that you were, anybody got any questions on this? Let me just check, somebody had asked something in the chat quickly while we're here. Okay, so in the lecture it says bone remodeling is not simple replacement. So what is it? Okay, so when bone is remodeled, okay, you don't just have like a whole section of bone that just gets destroyed and then replaced. All right, so when it is remodeled, it also includes factors like, well, if this bone is not being used that much, well, then we won't deposit as much as we actually destroyed. All right, because we don't need that much. But if this bone is being used more than it has been used, it will actually increase the amount it deposits. All right, so it's a dynamic thing. All right, so it's just not like, okay, we're going to destroy like 10 centimeters of bone and now we're going to replace 10 centimeters bone. If that bone is not being used a lot, it might only replace like 6 out of the 10 it's taken. Or if it gets used a lot, it might replace with 12 and when it destroys 10. Does that make sense, Nicole? I don't know if she's got, yes, okay. So that's just important to understand. It's not just a case of give and take. It's like at the whole time, the bone is basically being replaced according to the needs. All right, any other questions on bone? And then we'll just cover a little bit on joints before we go to muscle. All good? Okay, so I might stop sharing that one quickly. And let's see if I can find joints. Sorry, I'm just looking for it through the screen. There we go.
I should get my other one out.
All right, so if you don't have this one out, it's probably, there's not lots that you need to know here other than this table type thing. All right, so you need to understand the difference between fibrous, cartilaginous and synovial joints and be able to at least give a few examples of them. It again will be in multiple choice. So you will be given an example of a joint and have to decide whether it's synovial, cartilaginous or fibrous. Does that make sense?
Yeah.
Yeah. So you would also need to understand what the function is of synovial fluid and burses, all right, in joints. All right, and which are hyaline cartilage and which are your more fibrous cartilage. So hyaline cartilage is generally the cartilage on the end of your long bones, whereas your fibrous cartilage is the cartilage making up your vertebral, intervertebral discs and places like the symphysis pubis. All right, so those, just being able to differentiate between them. The difference between a ligament and a tendon. All right, so ligaments comes under joints, but we'll do tendons just now when we do muscles. And pretty much other than that, you don't need to know anything because from here it's just different. It was just your anatomy, I think. Let me just check. Yes.
Linda?
Yes.
I'm sorry, I didn't hear. What did you say before ligaments and the difference between ligaments and tendons?
Yeah, so you need to know the difference between a ligament and a tendon. A ligament is tissue. It's normally fibrous connective tissue that holds together a joint.
No.
And tendons we'll do when we do muscle, which is basically the attachment of muscles to bones.
Okay. Also, for the hyaline cartilage,
yeah.
supposed to know.
Sorry, for hyaline cartilage?
Yes.
What about it?
Oh, I'm sorry. I thought you said something about it.
For you need to know
cartilage.
Yeah, you need to know the difference, which is between hyaline cartilage and your fibrous cartilage.
Okay.
All right,
Perfect,
so
thank
your hyaline cartilage is generally the cartilage that covers the end of long bones, and it's normally in like ball and socket or hinge joints.
Mm-hmm.
Whereas your fibrous cartilage normally makes up, it's a much thicker, denser cartilage, much stronger, and it normally occurs in the intervertebral discs and also in the symphysis pubis.
Trying to work out which presentation you're going through. Is this articulations?
That was just the first part of the lecture on joints.
The articulations one?
See this, Tanya?
Thank
Articulation ones.
So I'm trying to work out which presentation it is.
It's
This
this
one.
one.
Articulations, yes, joints, articulations. That's it.
Yeah, that's what I was thinking. What page are we on now? Okay.
Sorry, my phone was singing in the next room. All right, so that's essentially what you need to know with joints. Is just, you don't have to learn all the different joints again. You did that in anatomy, but you just need to understand the different types of joints and like what type of cartilage is in it, and just how they classified. Does that make sense?
Mm-hmm.
All right, good. Okay, and then we'll go to muscle. Find muscle. Here we go.
We're going to muscle. Unfortunately, I didn't print that one. Exoskeleton.
So can you see the muscle one now?
Yeah.
Okay. All right. Okay, so again, look, a lot of your muscle lecture was identifying different muscles, and you don't have to know all the names of the muscles again now, people. You did that in your anatomy test, so that's not an issue anymore. All right, so it's just about now concentrating on the function of muscles and also the structure. All right, so that's what you need to concentrate on now. All right, so the first thing that you need to know is the difference between the striated cardiac and smooth muscle in terms of like, do they have intercalated discs? Are they multinucleate? Are they single nucleate? Are they branched? Are they unbranched? All right, so it's essentially this slide. All right, so basically striated muscle has got the nucleus around the edges. They've got the striations, and they're unbranched. Cardiac tissue has got a single nucleus. It's also got striations. It's branched, and it also has intercalated discs, which are these little discs over here. You can see there. All right, and then smooth muscle. It's got a single nucleus, small cells, tapered, a tapered shape as opposed to long fibrous like column shapes, and it's an involuntary muscle, as is cardiac, and skeletal muscle is voluntary. So I think I asked you when you did this lecture to do a table of that. Is that one of the activities? Yeah. So if you can fill out that table and learn that table, you're right. Okay, any questions on those?
No.
Okay, where is this thing? Sorry, my cursor keeps on disappearing now with all these windows. Okay. All right, so I just want to check through these quickly if there's anything that you need to know. This is all identification. Okay, so you just need to identify all those, basically be able to identify those things in terms of how they look like. All right.
Is that like a multiple choice, will it?
Yeah, multiple choice. Okay, the layers of your muscle, again, it's going to be multiple choice. So the first one is the one before it. So you need to understand the difference between like things like epimysium, perimysium, fascicle, endomysium, all those sort of things. All right, so it's the epimysium, yeah, for the person who was asking about, I can't even remember who it was now, who was asking about difference between tendons and ligaments. So basically this outer layer here of the muscle that basically enshrouds the whole muscle, that's the epimysium, and it continues and just basically that all comes together and forms a tendon that basically attaches this body of the muscle to the bone. All right, so that's what a tendon is. Basically all the pieces of the epimysium coming together and forming like a tendon. So the whole sheath basically forms like a tendon, and that's what attaches to the bone. So if you think of it, if you've got a sack, all right, that you've got things in, so you've got a bag of oranges, all right, and when you close the bag and there's this little piece that's stuck up in the top after you've closed it, that would be like equivalent to what the tendon is. So the actual bag is the epimysium around the oranges, and then the part that's actually left up after you've closed it, that would basically be equivalent to what a tendon is on a muscle, that piece sticking up at the top. Does that make sense? Yeah. All right, so in the tendon there's actually no muscle, it's just all connective tissue because it's basically extension of the epimysium. Okay, and then the perimysium, basically the perimysium enshrouds each fascicle, and the body of the muscle is made up a whole lot of fascicles. So you can see here, the perimysium basically goes around each fascicle, and then the endomysium goes around each of these muscle fibers. All right, and each muscle fiber is regarded as the cell. All right, so this is something that's also quite important for you to understand, is how, and it is in multiple choice questions, is how is the muscle cell different? So here it is, it's all sorted out for you. This is a nice slide to remember it by, because you've got the muscle as an organ, then fascicle, which is a bundle of cells, a muscle fiber, which is actually the cell, and then, the fibril, which is the organelles. Okay, all right, so how does a muscle cell differ from a normal animal cell? All right, so if you were asked to actually compare a muscle cell to any other cell, what would be the things that you would actually bring up as differences and similarities?
Contractibility.
Sorry?
Contractibility.
Okay, so in terms of function, it is contractile, yes. All right, so similar to the cytoskeleton, it is contractile. All right, what else?
Excitability.
Yes, it's excitable, can be, yeah, so there's something that can be stimulated to contract or can be excitable. What else? What about its shape? How does shape differ between a normal animal cell, like what you did when you had to learn the endoplasmic reticulum and all that stuff? All right, those round shaped cells, how does it differ?
This is long?
Yeah, okay, so a muscle fiber is actually a cell. So it's a long, thin tube-like shape, whereas a normal animal cell is normally a bit round and irregular shaped. All right, so immediately the shape is different. All right. What about the plasma membrane?
Of the animal cell, you mean? Or
Yeah, both. So what?
The sarcomere has the pits in it, the T tubules.
Okay, so yeah, we'll get to the sarcomere. just now? What is, in terms of the membrane, the plasma membrane, what is that? How is
Oh.
that different?
It's permeable.
They're both permeable.
Oh, okay.
What is it called in the muscle?
Sarcoplasmic reticulum. Oh no, the sarcoplasmic membrane.
So sarcolemma.
Sarcolemma, that's right.
Yeah, so the sarcolemma is equivalent to the plasma membrane in another cell.
Mhm.
Okay. All right. What about the nuclei?
There's multiple nuclei compared to an animal cell, which only has one.
Yeah, good, Sarah. Lots of nuclei. And where are those nuclei tend to be situated?
The edges.
Yeah, in muscle, particularly in skeletal muscle, it's right on the edges. All right, if you're looking at cardiac and smooth, it's normally more central, but on skeletal muscle, definitely on the edges. Okay, good. And they multinucleate. What about mitochondria?
It's only the, isn't it? Is it only the skeletal that are multinucleated?
Yes.
Because the cardiac and the smooth are single nuclear.
Yeah.
There's lots of mitochondria for energy.
Lots of mitochondria. So many more mitochondria in muscle cells than in other cells. Good. All right. Okay, is there lots of cytoplasm? In a muscle?
No, because it's sarcoplasm.
Yes, there is some, but it's not as much as that you would have in another cell. Does that make sense? So it's called now the sarcoplasm instead of the cytoplasm. Good. All right, and there isn't as much as it is in other cells. All right, what about the cytoskeleton?
Cytoskeleton.
Yeah. So your myofibril, okay, is equivalent to the cytoskeleton in another cell. All right, we know in other cells the cytoskeleton is minimally contractile, but in the muscle that has become a very functional organelle. All right, so your myofibril is a contractile like organelle in muscle fiber that you won't get in other cells. All right, what about the endoplasmic reticulum?
You have the sarcoplasmic reticulum instead.
Yeah, and where is the sarcoplasmic reticulum?
In the fiber.
Sorry?
In the muscle fiber.
Yeah, so it's wrapped around the myofibril.
Mm.
Okay, so if we go down to this picture here, let me just find this one for you. I love it when I can't find it. Oh, come on. Sorry. So annoying. So can you see this one?
Okay.
Mm-hmm.
Hang on a second.
All right, so here's the sarcoplasmic reticulum basically wrapped itself around each of the myofibers. All right, where's the sarcoplasmic reticulum in an, where's the endoplasmic reticulum in another cell? In a normal animal cell?
Right
Huh?
side.
Yeah, around the nucleus.
Yeah.
So like the endoplasmic reticulum, particularly the rough endoplasmic reticulum, hangs around the nucleus in a normal animal cell.
Yeah.
In the
we know.
muscle cell, it's wrapped it around this other organelle called the myofibril, which is essentially similar to the cytoskeleton.
And here it's attached, whereas it's not attached in the animal cell.
It is attached. It's attached to the it's attached to the nuclear membrane part of it in other cells.
Really?
Yeah.
I don't think I identified that when I looked
Yeah,
at it.
no, it is. It's attached to the nuclear membrane. In fact, there's some scientists believe that the endoplasmic reticulum membrane is actually the nuclear membrane. It's like, yeah,
Oh,
it's that closely attached. Yeah.
oh, right. Okay. That's interesting.
All right. So and this picture is pretty obvious where you can see this is the whole cell. You have the sarcolemma on the outside, which is the cell membrane equivalent. You have the myofibril, which is another organelle, but it's similar to what the cytoskeleton is in other animal cells. You can see there's the nucleus. Here the mitochondria in between, and there are lots of them. All right. And the other thing that the sarcolemma does is it actually has little pieces of it running down. So this blue that you see between the myofibrils, that's pieces of sarcolemma that actually run down like tubules into the actual and in between the myofibrils. All right, so it like envelops it, but they're like bits and pieces that run like fingers down into the whole myofibril system as well. All right, so that's important to understand for when we get to actually how this muscle cell is going to work. All right, okay. All right, so now let's go to actually, and this is pretty important. So we might just do a drawing here. That might be easier for you guys. Let me see if I can get a drawing up here and still share it. Okay. Okay. Come on. Okay. All right. So here you have your muscle fiber. All right, and it's wrapped by this is by your
Are you trying to show us something different to what's on the thing?
Can you not see that? Hang on.
No, well, I was only seeing what was on the presentation, but now I see it looks like you're sharing now, or about to.
All right. Okay, so you can see that now?
Not yet. Yes, now.
Okay. All right, so there's your muscle fiber. All right, and sorry, let me just get down here. It's wrapped around by sarcolemma. Okay, so there's a whole lot of fibers here. Okay, so you'd think there'd be a whole lot of fibers running next to each other like this. Okay, and the sarcolemma is running in T tubules down all the way between them. Does that make sense? All right, and then wrapped around here is your sarcoplasmic reticulum. All right, around each one of those things. What's in the sarcoplasmic reticulum that's important for muscle contraction? Does anybody remember?
Calcium.
Calcium. Okay, so the sarcoplasmic reticulum here is full of calcium. Okay, so here you have your neuromuscular junction. All right, and it's basically sitting on the edge of the muscle. All right, and this is continuing like this. Okay, so here comes your nerve impulse. What happens? You can tell me.
Crosses over the neuromuscular junction, releases the
Okay,
acetylcholine,
so before it can cross, what does it need to do?
stimulate the production of acetylcholine.
Okay, so you've got little vesicles here that have got acetylcholine in them. Okay. All right, and they in vesicles. All right, so what happens as soon as the nerve gets down there and it stimulates one of these vesicles, it causes the end bulb, this is called the end bulb of the nerve, all right, to secrete those vesicles and open the acetylcholine into, what's this called, this place here?
Synapse.
Yeah, the synapse, all right, or the neuromuscular
Synapse.
junction. All right, or it's called the synapse or synaptic cleft. That's another word. All right, that acetylcholine, what's sitting on the surface of the muscle here, all along here, on the sarcolemma,
Calcium.
what's sitting there?
Sarcoplasmic sarcolemma with the calcium.
These things are called receptors.
Mm.
All right, so as soon as the acetylcholine gets into the gap here or into the synaptic cleft, it binds onto the receptors.
Mm-hmm.
All right. Essentially, those receptors create an action potential, which is another electrical stimulus.
So,
All
sorry,
right, so what you've got is an electrical stimulus giving you a chemical, which is your acetylcholine, which then is basically attached to the receptor, which then initiates another electrical stimulus. Does that make sense?
Mm-hmm.
This is the process that's having. You've got electrical causing release of a chemical. The chemical then attaches to a receptor. The receptor then creates an action potential, which is another electrical stimulus. All right, let's just check somebody's answering question here in the chat. Would you be able to explain acetylcholine again? Sorry. Okay. All right. So acetylcholine is in these little vesicles. All right. It's a neurotransmitter. In other words, it's used to transmit messages from a nerve to a muscle. Okay. So when the electric stimulus gets to the end bulb that has these vesicles full of acetylcholine, the acetylcholine gets released out of those vesicles into the gap between the nerve end bulb and the muscle. On the muscle side, there are a whole lot of receptors. The receptors pick up the acetylcholine, or the acetylcholine attaches to the receptors, and that initiates an action potential, which is an electric stimulus that runs along the whole length of the muscle fiber. And not only does it do that, it runs down into these clefts, all right, so that it actually can reach fibers further down in the system. All right, so you have this action potential reaching down there. Is everybody clear up until this point? Grace, did you get it about the acetylcholine? Just send me a text in the message if you can't go, if you can't.
Is this going to be a long question, Linda?
Yes.
Oh no.
Yes, definitely long question.
How many marks?
Maybe 10.
Oh dear.
I'm just not up for this, I think.
So just basically understanding acetylcholine.
Sorry, Emma, your mic is very fuzzy, so it's very difficult to hear.
It's basically understanding with the acetylcholine.
Maybe you should
do me a favor. Won't you just write it in the chat?
Okay.
Because the mic is really funny. Let me just wait for Emma to write her question down, then we can carry on. Has anybody else got questions on this part?
Linda, will that be about the entire muscle